hi, come on in.
Hi.
Welcome to my Making Math Meaningful Lab.
Cool. What's going on?
Well, I was just playing a game of darts here.
Darts? What does that have to do with math?
Well, step on to my math later and I'll explain.
Mathalator? What's that?
What does this look like?
Looks like a normal treadmill.
What do you do on a normal treadmill?
You walk or jog or run.
You walk or jog or run at a certain,
Rate.
for a certain amount of
Time.
What do you get when you multiply the rate and time?
Distance. Oh, I understand why it's called a mathalator.
And my math later is special because it helps you to see the math around you.
Math around you? Oh, like the dartboard we talked about earlier.
That's right. So before you came, I was playing dots and I threw 4 of the dots and 2 of them fell right here and 2 of them fell right there. Now I was trying to figure out where should I put the 5th dart so I can get the most amount of points. What should I do?
The bullseye.
That's what most people think. Now, the bullseye is about 50 points for each dart. I already got 2 of them there. So each dart is worth 50 points. Let's suppose I was only going to throw 3 darts. Now, each of those darts is 50 points times 3. What's 50 times 3?
50 plus 50 plus 50.
Ah, I see what you did there. I asked you 50 times 3 and you did 50 plus 50 plus 50 because multiplication is?
Repeated addition.
That's exactly right. So 50 plus 50 plus 50 would be?
150.
That's right. If I got all 3 of my dots in here, I would get 150 points. Then I started thinking about the entire dartboard and all those numbers there and all those regions that they represent. There are larger regions where these numbers will be the exact number of points you will get. And then there are these smaller regions. If you are on the outer smaller region, you actually get twice the number of points. If you're on the inner smaller region, you actually get 3 times the number of points. So my other 2 dots actually fell in the inner region corresponding to 20 points. So each of those dots would be worth what?
Well, that's 20 times 3, so 60.
So each dot is 60. There's 2 of them there. And if I get my 3rd dot in here, then how many points would I get with those 3 dots?
Well, that would be 60 times 3, which is 180.
And did you know that with only 3 dots, that's the maximum amount of points that you can score on a dartboard?
No, but now I know how to win at darts.
That's right.
Oh, hey, what's back there?
Oh, that? Welcome to my drone zone.
Drone zone? Cool. Is that a real drone?
That's exactly right. And it actually flies.
Can we build one of those?
Sure. But first, we have to build a prototype.
Prototype? What's a prototype?
Funny, you said that.
So what's prototyping?
Oh, prototyping is an important part of engineering design where you try to make a model.
So we're going to make the model of a drone?
Funny you should ask. So in order to build a drone, we need some materials.
What materials?
Well, we start with 2 giant popsicle sticks and we need 4 small popsicle sticks. If you get colored, that's great. Then we need some stickers, some round stickers, some rectangular stickers, and then some kitchen sponge and a stapler. With these, we can actually build the model of a drone.
Great, let's get started.
Okay, so we start with 2 popsicle sticks and we're going to put it in the form of the frame that you see here of the drone. And this is actually called a quad.
Quad as in quadratic?
That's right. But the quadratic in quadratic equation is usually squared. Do you know why?
Well, a square has 4 sides.
That's exactly right. And this frame has 4 sides to it. And therefore, this is called a quadcopter that we are trying to build. So the first thing that you do is put 2 of these giant popsicle sticks, take a stapler, of course, be careful when you're actually working with a stapler, and simply staple. When you do that, you get something like this, which is basically a quad. The next thing that you do is actually take some of these round stickers and stick them to simulate the motor. And when you do that, you're going to get 4 motors that are stuck at the corners. Now, once you have the motors there, the next thing that we could do is actually take the smaller popsicle sticks, which is like the propellers that you see here, and simply take your stapler. Once again, be careful and start to staple. So I'm going to staple it for you here, and I'm going to just have the same colors on opposite sides, and I'll tell you the reason why in just a second, because in general, for the drone to fly, the propellers that are on the opposite sides, they go in different directions. One goes in clockwise and the other one goes anti-clockwise. So once you have the propellers in place right on top of the motors here, the next thing that we need is for the motors to spin at a certain speed, we need to have electronic speed controllers. And for that, I'm going to use these rectangular stickers, and usually they're at the bottom of the drone. So I'm going to put those stickers at the bottom, just like you saw it in the real drone. So I'm going to put that in the bottom, and then I have to have the fourth sticker also here. So once you have those, the next thing that I need is to have a flight control that's going to control the electronic speed controller. So I'm going to use a kitchen sponge for that, and once again I'm going to keep it on the top. It's very easy to staple it, so I'm going to use the stapler once again. Once again, be careful, and I staple it, and I have my flight control. But none of them is going to work if I don't give it sufficient source, energy source. And the energy source is a battery. Just to make sure the color is a little different, I'm going to use a different kitchen sponge, and I'm going to put the battery in the bottom of the drone, and then I staple once again. And when I do that, I've actually put the battery on the bottom, and the drone is almost ready. The only thing is, we need to make sure that the flight control is giving instructions to the electronic speed controller that actually tells the motor to rotate at a certain speed, so that the propellers will actually rotate in different directions and the drone will start to fly. So I need to make those connections. So how do I make those connections? Engineering. I need to have circuits. And so what I do is start to connect them. So I have these electronic speed controllers. These will be connected like that. Pretend that these are wires. I could use different markers, one red, one black, for example, and actually connect them in the bottom just like this. And on the top, I'm going to have some more connections like that on all four sides. So when I do that, then I'm actually connecting from the flight control to the point where the electronic speed controllers are there. The electronic speed controllers are connected to the motors, and the motors start to rotate, and which rotates the propeller, and the drone flies. Congratulations, you made a drone under 3 minutes.
That was so fun. Can we do more math activities?
Of course. Do you like numbers?
Yeah, if they're fun.
Oh, funny you said that. Well, do you like magic?
Yeah.
Let's do numbers and magic together. Get ready for some math magic. Can you tell me a two-digit number?
24.
Okay, 24 it is. Okay, do you see this blank paper? There's nothing on either side. Do you agree?
Yep.
Okay, so I'm going to write some number here in big that you don't see. I'm going to put it down. I'm going to ask you for another two-digit number.
38.
38. So you said 38. Now, it's only fair if we play this game back and forth. So I'm going to write down a number. Let's just say 61 is my number. Now it's your turn.
54.
54. You said 54. Once again, we are playing this game back and forth, so it's fair. So I'm going to write down 45. Let's pause for a second and start to add these numbers. So add with me. 4 and 8 makes
12.
12 and 1 makes
13.
13 and 4 makes
17.
17 and 5 makes
22.
22. So you put the 2 here, and what do you do with the other 2?
Carry it to the top.
You carry it to the top. 2 and 2 makes
4.
4 and 3 makes
7.
7 and 6 makes
13.
13 and 5
18.
18 and 4
22.
22. Now, how do we check our work in general?
Well, I just add them again.
Add them again? You're going to waste time doing it. How do you know you're right? Well, what do you think adults do?
Use a calculator.
Of course, adults will use a calculator or a cell phone perhaps, but those are machines. Who made those machines?
We did.
Humans, of course. How can machines be smarter than us? Let me show you what I had.
Wow. How did you guess that?
I told you it's math magic. It's for you to figure out.
That's so cool. So, can you do some multiplication activities?
Oh, come with me to the multiplication station here. I already have set up the problem for you. Let's suppose you want to multiply 12 times 13. This is the traditional way you usually learn. But do you know why we put this 0 here?
No.
Well, there's a good reason for it. If you were to think of the 12 as a 10 and a 2, and a 13 as a 10 and a 3, the first thing that you usually do is multiply the 3 and the 2, which gives you a 6. And the next thing that you multiply is 3 and a...
1.
Wait a minute, is that really a 1?
No, it's a 10 place value.
That's exactly right. Units place, tens place. So you multiply 3 times 10, that gives you 30. 10 times 2 gives you 20. And 10 times 10 gives you 100. It's the same problem, but done in a much more simpler way. And this is called partial products. Very easy to understand. In fact, if you were to draw this, we can think of a garden which is of length 10 feet, that's this 10, and followed by 2 feet, that's this 2, so that represents 12, and then a 10 and a 3, that's across the length, that's 10 and a 3, which represents 13, and that forms 4 shapes. And the area of each of those shapes are the exact same numbers that you actually see in the partial product, and so the total once again is 156.
Wow, that's so cool.
And that's a visual way to actually learn about multiplication. And for those that like algebra, you can simply think of this 10 as an x and this 10 as an x. So you're multiplying x plus 2 times x plus 3, which I've written out here.
Oh, it's just FOIL.
That's exactly right. You take the first terms and you multiply and you get x squared. You take the outside term, which is a 3x, and the inside term, which is a 2x. Since they're like terms, you get 5x. And then the last terms, that gives you a 6. But watch the terms that I've circled. What do you see?
It's 156. Wow, that's so cool.
Arithmetic meets algebra.
Wow, I didn't know there were so many ways to do multiplication.
Well, it's not over yet. I just saved the best for last. Now, I'm going to draw 2 lines. What do you see?
I see a 1 and a 2, like 12.
That's exactly right. Modern art to represent 12, 1 and a 2. Now let's try 13 this way. So I'm actually drawing 1 and a 3. Now, what I'm going to do is I'm going to actually partition this way to denote the units place, the tens place, and the hundreds place. I want to see how many places these lines meet. 1, 2, 3, 4, 5, and 6. So let me write this down. And in the center, 1, 2, 3, that actually corresponds to the 30. And 1 and 2, that corresponds to the 20. And that gives me the 5. And in the corner, I get 1. And guess what I get when I actually put it together?
It's 156 again.
Math through art.
Wow, that's so cool.
Before you leave today from my Making Math Meaningful lab, I have a small challenge for you.
Cool, what is it?
Well, do you see these movies on screen?
Yeah.
Well, can you guess the first movie?
Sure. It looks like an American flag and pie. So, American Pie.
Exactly, that's American Pie. Can you get the second one?
Well, there's a brick wall and a long number. I think it's irrational, like pi, but I don't know what it is.
It's a very important number. And it has something to do with the number E. E for Euler. Euler sounds like boiler, not ruler. But here is how we remember E. There's only 2 things you need to know about Andrew Jackson. He was the 7th President of the United States. He was elected into office in 1828. I repeat, 1828. Like every good mathematician knows, the angles of an isosceles right-angle triangle is 45, 90, 45. Like I said, you just need to know 2 things about Andrew Jackson. Better than any computer.
Wow, that's so cool. Now I know all of E.
Thank you for spending your time in the Making Math Meaningful Lab with me.
Thank you.